This is 1.6 in your textbook, page 57. Looking over this lesson, I want to go through example 1 quickly with you guys, but I just want you to look at your textbooks, okay? There's no point in drawing this on the board. Again, it's kind of a funny question. I just don't want to leave it out per se, but I don't want to actually draw it all out on the board. That's kind of a number line. Page 57. I'll have Chris read at the back, very loud. It says, Taylor walks.
I've got my pencil case, I forgot my locker.
Taylor walks.
My locker's like right beside the classroom.
Yep.
Taylor walks one lap around the track. Then she turns and walks half as far in the other direction. She changes direction again and walks half as far as her previous distance. She changes direction one last time and again walks only half as far as her last distance.
Okay, so you can see that they've drawn a number line here. The question says, what fraction around the track is Taylor's final position? So she walks one direction to 1, then she walks back the other direction back to a half. That's the blue line. And then you can see number 3, she walks again now half that distance, so it was 4 points. Now she's going to walk 2 points, and finally the 4th line, she walks 1 point. It's just asking what position on the number line is she at. So everybody can see that's 5/8. Pretty simple, right? Okay, so I'm not sure why they started with that question. It doesn't really relate much to the homework. I do want to kind of point your attention now to page 62 though. So there's a summary chart here, and this is a good lesson for you guys. Use this summary section. If you're going back in the textbook and you want to know what was this lesson about, you don't want to read through the whole thing, go to the summary at the back. Because this, a lot of times, as you get older, they have this in the other textbooks as well, the McGraw-Hill. This will give you all the equations you need in the homework. Okay, later it'll be equations and formulas. It'll be in this summary area. So it's a good tool to use also, that if you're just going back to the lesson like, oh, what was that equation, what was that formula I needed? You're going to check this section in summary. Okay, so I just kind of reviewed that. I copied that down here. I just want to go over a few things. So powers of rational numbers. So again, we're talking about powers of, kind of think of rational numbers as fractions, right? So powers of fractions. So when we have a power, A and B, of course, these letters could represent any number. Okay, and we have an example here for each one of these. But when we have a fraction to a power, it's important to recognize that it's the whole fraction that gets raised to that exponent. I said to a power, it's actually to an exponent. Remember the whole thing, this whole thing is called the power. This is the exponent, this is the numerator and the denominator. This fraction in this particular power would be called what? Anybody? Just Michael.
The base?
Yeah, the base. Very good. So this would be called the base, the exponent, and the power. Okay? So the important thing is, when you raise a fraction to an exponent, you have to recognize that that exponent belongs both to the numerator and the denominator. A lot of people want to just apply it to maybe the numerator or just the denominator. You've got to understand that it applies to both. And the reason why is that you can see what's happening here. As we multiply these fractions, remember A is getting multiplied by A, so it's raising up that number, whatever the exponent is. Same thing is happening on the bottom for B. Okay? It's not like addition of a fraction where we're only adding the top numbers and the bottom numbers saying it's the same. It's a multiplication where you multiply the top across the top and across the bottom. So that's very important. This exponent applies both to the numerator and to the denominator. Now, dealing with negative signs. If we have a negative sign outside the brackets, we've talked about this already. This exponent only applies to what's inside the brackets. So you're going to ignore this negative sign when you're dealing with this power. You're going to evaluate this power and put the negative sign in at the end. Similarly, how we talked about dealing with a mixed number. When you're converting mixed to irregular, leave the negative sign outside, convert it to a regular fraction, then reinsert the negative sign. Okay, so that's what's happening here. This negative sign stays on the outside. We deal with the exponent and the power, and then that value stays negative. Yeah.
So the answer, if the negative sign is outside the bracket, the answer will always be negative?
Yes, always. Doesn't matter what value this is going to be. Okay, so just showing that as an example. So the first one, when we have a fraction, again, raised to an exponent, it's the fraction multiplied by itself. So in that case, it's actually 2 raised to the exponent of 3 over 3 raised to the exponent of 3. Okay, you can see that here, which gives us 8 over 27. When we deal with that negative sign, again, keeping the negative on the outside, we deal with this multiplication first, which is the same as here, 8 over 27. That negative sign stays in front. Does not matter if this is an odd number, even number, the value is still going to be negative. Why? Because that exponent is only dealing with whatever's inside this bracket. Okay, that negative sign stays on the outside. When we have a negative sign inside the bracket, whether it's like this, whether it's like this, or whether it's like this, okay, remember, all of these things are the same. Whether you put the numerator, the negative sign with the numerator, with the denominator, or in front, they're all the same. Typically, I wouldn't want to see something like this. I would write it like that. If you want to just include it with the numerator, you can write it like that. Now, when we have a negative value raised to an exponent, that exponent now, if it's odd, we're going to get a negative value answer. If it's even, we're going to get an even valued answer. And the whole reason why is because a negative sign times a negative sign is positive. That's why if we're multiplying by an even number here, we're going to cancel the negative signs out. So if a and b is less than 0, so in other words, if a and b is negative, that's all this is saying. If a and b is negative, then a over b raised to n is positive if n is even, and negative if n is odd. Okay, and that's an example right here. Right here. So we have negative 2/3, so this is a negative value. We're raising it to an even exponent. We're going to end up with an even answer. Okay, and that's because we're multiplying a negative times a negative. When we raise it to an odd exponent, we're multiplying it 3 times now, so that negative sign gets reintroduced, right? So it's going to be a negative answer. If you can memorize this, that these even is positive, odd is negative, then you can almost ignore that negative sign and put it in on the end, right? Deal with the power, deal with the exponent to the numerator and the denominator, and then insert that negative sign on the end because you know it's odd. Any questions? Okay, let's go through some of the other examples. I don't know how this is much different than before, but typically, so it has Ahmed's solution here. This is on page 59 in your textbook, and Faith's solution. The only difference here is that Ahmed decided to do more steps. I'm sure Ahmed is still using a calculator here. I don't think he's doing 3.2 squared in his head. So he's not converting to fractions. So the only difference here is that Ahmed is doing more steps. He's doing negative 3.2 squared, he gets 10.4. Even exponent, negative base, it's an even exponent, you're going to get a positive answer. Then he subtracts 2. Negative value now, we're going to get a negative answer. It's important that you can use your calculator, but it's also important that you can recognize that this has to be negative so that if you do type something in wrong, you're going to still get, you're just going to catch yourself. When we have a negative sign, negative negative becomes positive. You can also think of it as negative 1 multiplied, right? This is in front of the brackets. Multiplied by negative 549, it's going to be positive. Any questions there? 1.24 positive. No questions? Okay, and then finally, now if I would write this on my calculator, so that's one solution, this is Ahmed's solution. Faith's, which is much easier, I would have just put negative 3.2. I'll put this button, or this button, whatever your calculator has. And to put this negative sign, remember the difference. I think most of your calculators, the button looks like that, as opposed to just a negative sign. Okay? Where this button is negative, so this is a minus, whereas this button is negative. Okay? Yes.
So sorry, how did you get the 1 on the first step?
Here?
Yeah.
Because when you don't see a number there, it's just negative bracket, you have to assume that there's a 1 in front of that bracket. That's what that means. They just don't write it.
Oh, but like,
Okay.
but then you start off with a 2 though.
Oh,
Yeah.
no, I multiplied it though.
Oh, you already multiplied
Yeah.
it.
So I multiplied the 2 in.
Oh.
That's what gave me the 274 to 549.
Oh.
Okay? Yeah.
So do you really have to put the 1 or do
No,
we,
you don't.
you already know what the, like,
If you know negative, negative is positive, you're fine.
Oh.
Any other questions? The problem would be, Daniel, is if you had something like this. Let's say that. So this is not
What
Okay.
would it be?
that negative sign has to be distributed to both.
Oh.
Okay?
So it has to be.
So it would have to be equal to positive 5x minus 2. Okay? So that's where that concept of taking the 1 and distributing it, changing the signs. Okay? We're going to see more of that later.
That negative sign would go to the 2.
Yes.
So it'd be negative 2, wouldn't it?
Right, yeah.
But then at least there's a plus.
No, but I've done it now. So that becomes this.
Oh.
Yeah.
But, so you can't subtract it, you can't say 10.24,
Hmm?
no, I think, you can't say, you don't say 10.24 subtracted by negative, you don't subtract it,
No, you're going to add it because it's a negative, negative. You are subtracting a negative number, so you're adding a positive number. Yeah. You do. You're subtracting it. I don't know if I confused you guys with that 1 there, but yeah, you're subtracting a negative number so it becomes positive. Okay? This negative 1 concept comes into play when you need to distribute to multiple values within the brackets. Okay? Yeah.
We'll learn that later on, right?
Yes, yeah. You guys haven't seen this yet?
No.
Oh, okay. You might have. You will learn that later on. Okay, so that's example 2. See example 3. Okay, so here we want to deal with bed mass, so the first thing we want to do is work within the brackets. But I know I'm not going to touch this, I'm just going to change it. So I'm just going to change it from a mixed number to an irregular fraction. So I multiply 2 times 3 is 6. Remember, don't worry about the equal sign or the negative sign when we're dealing with converting a mixed number to an irregular fraction. We can leave that minus sign alone. Negative sign, so we have 6 plus 2 is 8. We have 8 over 3. Now we're going to convert this one to 4. Make this subtraction, now we need to convert to a common denominator, which is 12. If you didn't know that, you could go to 12. You could have went to 24 by just multiplying them and then reducing after. This is all squared still that whole time. Because it's a negative number, but it has an even exponent, it's going to be a positive value. Got one extra step that I'm leaving out from here to here is, of course, you guys are perfectly comfortable with that, right?
Yeah.
Okay. Finally, we need a common denominator between the 3 and the 144. The trick with, here's a trick dividing by 3. If you want to know if this number is divisible by 3, you can add up the numbers. So 4 plus 4 is 8, plus 1 is 9. Is 9 divisible by 3? Yes. So 144 is divisible by 3. Okay, it's a little trick. Some of you already know that. So that means I know 3 goes into 144. And how many times is it?
But doesn't the numerator also have to go into
12. Is it 12 times? Is that right? Times 12?
No.
What is it?
20?
It's 20.
Sorry, 28. I'm way off. 3 times 28 is 144?
48.
It's 40.
3 times 48 is 144. So what's 8 times 48?
384.
So what's negative 384 plus 961?
1,350.
No, it's a negative plus a positive.
Oh,
577.
And then you're going to convert this to a mixed number. Remember the easy way I taught you how to do that is you take 577 divided by 144. You put the whole number down, which is 4. Whatever decimals you're left with, you can multiply it by 144. And that will give you the numerator. Okay? Any questions there? Jesse?
how come you don't use a negative?
How come, sorry?
From 8, you don't see how come you don't, in the beginning. How come you don't use negative?
How come you don't what?
Like negative 2 times 2.
No, because when you convert from a mixed number to an irregular fraction, it's still going to be negative. You're not changing the number. So you can't say negative 2 times 3 is negative 6 plus 2, then we'd have 4 over 3. Negative 4 over 3. That's negative 1 and 1/3, right? So it's not the same. That's why you can't do that. Okay, so you gotta ignore the negative when you're converting from a mixed number to an irregular fraction initially. Alright? Alright, the last example is example 4. It says Jose worked at the mall this summer to help pay for her future university education. She invested $3,000 in an account earning interest at a rate of 3.5% per year. How much will her investment be worth in 4 years? So, in example 4, they give you this equation. They say the amount that she invested will be equal to the principal amount that she invested multiplied times 1 times the interest rate she's gained, all raised to the exponent of n, which is the time. So they give you that formula and they tell you what each thing is. So your job, it's like a physics question, okay, is you need to find the values of these variables. And then we need to substitute them in. Okay, this is what physics is all about. Except we're dealing with motion equations and the other equations to do with physics. So it says, how much money will her investment be worth in 4 years? Well, that's what A is, so we don't know what A is. So A, we're just going to leave it as A. It then says P is the amount of money invested. So what is that from the problem? Nicholas, how much did she invest?
Me?
Yeah.
I wasn't on the right page.
No? 61. Solid, how much did we invest?
$3,000.
Good. So P is 3,000. What's I? I is the decimal value of interest rate used at each time interest is earned. So Kevin, what's the I?
3.5.
Good, but the decimal value, what's the decimal value of 3.5? So you're right, it's 3.5%. What's the decimal value of that? You guys know how to convert from percentage to decimal? Yeah, Kevin?
0.035.
Excellent. Not 35, but 0.35. You got to divide by 100. Okay? And finally, N, Mark, what would N be? It says the number of times interest is earned while money is invested. So what would N be?
4 years.
Yeah, 4. So it's 4. Okay, so now we have all of our variables except 1. And to solve any equation, if we can have all the values except for one, then we can solve it. So we're just going to go ahead and substitute in. When we substitute, remember, we like to put brackets. So all I've done was taking those values, and where I had my values known, I substituted them into the formula. And now you could put this right on your calculator, okay? If we wanted to do a little bit of work first, we could say 3,000, 1.035. I've just added those to the exponent of 4. Finally, so the question reads, how much money will her investment be worth in 4 years? So David, how much is the investment worth?
In 4 years.
Yeah. Really? You're not with us?
Sorry.
Somebody else will pick on. Philippe. How much is the investment worth in 4 years? Come on, guys. It's disappointing.
$3,442.
You going to the book? You can't see this? What am I doing up here? You didn't look in the book for that? It's right here, right? That's what we're doing, right? Come on, guys. Stay with me. So how much money did we earn on interest? Kevin, over here. How much did she make with this investment?
She made $440.
Excellent. So Kevin did in his head, he did this value minus how much he initially invested. Very good. So that wasn't the question, but that would very likely be a question in your homework. How much did she actually make from the investment? Well, she made the difference between what she invested originally and what she got out at the end. Any questions?
Shouldn't you do the exponent first? But then when I did that, it gave me a big decimal. You do one-
Yeah, I did this
yeah,
together on the
you skipped
calculator.
a step, right?
Yes.
But like, if I was to not skip it and then I did that to the power of 4, I got a big decimal. Do I write every single number?
Yes. You should always carry all the decimals to the end and then round.
Oh.
Okay? It's going to be the highest level of accuracy. All right, if no more questions, then that's the end of 1.6.